Hello, the Math Dog here. This is the second video in a set of videos on graphing rational functions. This is part 2. This is going to look at what we call holes. Part 1 was looking at the basic rational function 1 over x squared, and then some variations on 1 over x. We talked about horizontal asymptotes, vertical asymptotes. We looked at x and y intercepts and domain and range and so forth. So let's get started here on holes. So what's a hole? Well, let's look at this function f of x equals x squared minus 2x minus 3 over x minus 3. Well, turns out this can be factored because two numbers multiplied negative 3 add up to negative 2 would be 3 and 1. Or 3 and negative 1, or negative 3 and positive 1. So that factors like this. That'll be over x minus 3. Again, so the inside's negative 3x, the outside's 1x. Negative 3 plus 1 makes negative 2, which is what I need for there. So now, don't rush and just don't cancel out the factors and go, okay, well the result's x plus 1. Well, it sort of is, except you have a little problem here. X minus 3 cannot equal 0 because that would be division by 0. So adding 3 to both sides, you get x cannot be 3. Okay. So there is a restriction on the domain here that x cannot be 3. Okay, so where is y going to be located? Well, let's look at that. So first of all, let's simplify this function now. Now that we have this, we can go, those cancel out, so we end up with f of x equals x plus 1, but we must state that x cannot be 3. So what I do is, as x approaches 3, f of x is going to approach 3 plus 1, which is 4. So the hole is located at 3, 4, 3, 4. So on our graph, we're going to have a hole at 3, 4. The function goes through, the y-intercept is 0, 1, or 1. Slope is 1, so 1 over 1 up. There's a hole, and then it just continues on like so. So to complete a sketch or graph of the function, it's going to look like this. Now remember, technically a hole, a point or lack of point, has no space or area. So when we do it on like a graphing calculator, we won't see that hole. We'll have to make a table, and that's what we're going to do. But before we do that, let's give the domain and range of this function. So the domain is going to be negative infinity up to this hole, which is at negative 3 for x. Does not include 3, so we put a parentheses there instead of a bracket. Then it starts again, 3 to infinity. The range is going this way vertically, so it's negative infinity. Then at 4, there's a break, so it's negative infinity to 4 union 4 to infinity. You could find the x and y intercepts by, again, the y-intercept is the function when it's evaluated at 0. F of 0 is going to be, just use the simplified function here. There's your final function. Is going to be 0 plus 1, which is 1. And there's the point right there, 0, 1. Okay, then the x-intercept is when, again, this is the line y equals 0. The x-axis is the line y equals 0. This is the line x equals 0, the y-axis. So what I do to find the x-int, we set the function equals 0. So 0 is equal to x plus 1. So x has to be negative 1. So the x-intercept is negative 1, 0. And there it is right there. All right, let's continue. So suppose I have this function f of x equals x squared minus 2x minus 15 over x minus 5. Okay, well, this should factor two numbers that multiply negative 15 add up negative 2 are be negative 5 and 3, so I could write x minus 5 times quantity x plus 3 over x minus 5. Okay, so again, before we just start canceling out, we note that x minus 5 cannot be 0 because that would be division by 0, so we get x equals 5. Okay, now this is not a vertical, not going to be, these holes are not vertical asymptotes, okay, because the function doesn't hug these things like a vertical asymptote we showed in the first video for 1 over x goes like this. It hugs, starts to hug this line x equals 0. Okay, so x cannot be 5. Now we can simplify it, so this is going to be x plus 3, but then we need to state that x cannot be 5. Okay, so we simplified it to x plus 3, x cannot be 5. Okay, so where's the hole located? Well, again, as x goes to 5, what happens to f of x? Well, f of x goes to 5 plus 3, which is 8. So we have the hole at 5, 8. So we can mark that on our graph. 5, 8 is right here. Okay, so now the simplified function is x plus 3. So that's going to mean it's going to have a y-intercept of 3, or 0, 3, and slope of 1. Okay, so let's graph that. Alright, so we have a hole at 5, 8. There's the graph of x plus 3, x cannot be 5. So let's just take care of the domain and range now. So the domain is to be negative infinity, and it breaks at 8. Right here, going this way, going across. Union 8 to infinity. The range, again, is going up and down. That's negative infinity. There's a break. Did I say it's not at 8? The break is at 5 for x. That's a mistake. The break should be at 5, then union 5 to infinity. The range now goes from negative infinity to 8. Union 8 to infinity. Okay, so going through my list here, there are no horizontal asymptotes here. It's not hugging anything, okay? There are no vertical asymptotes. There's none. There's none. None. A hole exists at 5, 8. Okay, so there are going to be no slant asymptotes. We haven't addressed that yet. So x and y intercepts. We did domain and range. So x and y intercepts. So remember to find an x-intercept. Let's draw in the, let's highlight the x and y axes here. So there's your x-axis. Remember the equation of the x-axis though is y equals 0. Okay, so, and then the vertical axis or the y-axis has the line x equals 0, the vertical line, and then this is the y-axis. Okay, well you can see from the graph where it's going to be, but I'm going to do it using pencil and paper. So the x-intercept is, again, we set the function equal to 0, okay? And we can set our simplified function equals 0, which is going to be x plus 3 equals 0. Solving for x, we get x equals negative 3, which is right there. So our x-intercept has coordinates negative 3, 0. The y-intercept is where the function has a value of 0, so the y-int is going to be found at f of 0. F of 0 is, the function is x plus 3, so that's 0 plus 3, which is 3, so the coordinates are 0, 3 for the y-intercept. Okay, so the y-intercept is 0, 3. pretty much concludes the analysis of the function, but I'm going to now go to Desmos and show you what I'm talking about, that you can't see this until you do a little investigation on the graph. So if I put my original function in there, which is x squared f of x equals x squared minus 2x minus 15 all over, I need to put a parentheses here too, because I need to have that entire expression divided by x minus 5. Okay. Alright, so there's our function graphed. Okay, you don't see, okay, let's move this down a little bit like that. Okay, you don't see a hole. Again, a hole takes up no space. So what I'm going to do is I'm going to create a table, and I'm going to change this to x, change this to f of x. Okay, now I'm going to start the table. I'm going to start it at -4, so I'm just going to keep going. -3, just keep going. But notice then finally at 5 we get undefined, and if I keep going it starts going again. So there's our hole. The x value is 5, okay, and the y value we found taking the limit there. Let's go back to our thing now, my page. We found it to be, the hole is at 5/8. Okay, so let's do another one. So we're gonna, this is actually, you're gonna stop the video here. This is a practice video. So just a little hint here. So I assume if you're in this, doing this video, you're probably at least in Algebra 2. So you've seen factoring by grouping. So that's what you're gonna have to do in the numerator here. You're gonna have to use factoring by grouping. So stop the video, get a piece of graph paper and see if you can do this, and then I'll start the video again and I'll go over the answer. Okay, so let's take a look at this function. I've got f of x equals x cubed minus x squared plus 2x minus 2. Well, notice there's a common factor of these two, of x squared, so I'm going to write this as x factor out of x squared. That's going to be x minus 1. Notice here there's a common factor of 2. So I can factor this like this all over x minus 1. So now I have a common factor here of x minus 1, so I can write x minus 1 times quantity x squared plus 2 all over x minus 1. Okay, so again we notice that right away x minus 1 cannot be 0. Okay, so x cannot be 1. That's going to be a hole. Okay, so now I can cancel that. So this is going to be x squared plus 2. So my function, my answer, or my function is going to reduce to f of x equals x squared plus 2. X cannot be 1. So what's the y value for this? Well, what we do is as x approaches 1, what happens to f of x? Well, f of x approaches 1 squared plus 2, which is 3. So our hole is at 1, 3. We have a hole at 1, 3. Again, this function is going to have no vertical and horizontal asymptote. Okay. So, and we still aren't dealing with slant asymptotes. That's a later topic in another video. So we got a hole at 1, 3 right here. Now what's x squared? So let's circle, here's our function. So what's x squared plus 2 look like? Well, it's simply a parabola shifted up 2 units. So again, the parent function for f of x equals x squared is going to be, remember, and I'm going to treat this as my new origin, x f of x. So for example, negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So let's put a couple points there. Well, we can't put a point there. We don't have to though. So that, yeah, that would actually be 1 up. So the parent function x squared is 1 over 1 up, 2 over 4 up. And we don't have room for 3 there, but we'll go 1 over 1 up here. 2 over negative 2 squared is 4. So our function sketches something like this. And there's our hole at 1, 3. Okay, it's a parabola, except it's not exactly a parabola. It's got a parabola with a missing point. Okay, so now let's do the x and y intercept. So the x-intercept, notice there actually isn't going to be one, but the x-intercept, the way you find it is you set x equal to 0. I'm sorry, you set x equal to 0. So let's first of all, let's draw on these axes. Let's label these equations of these x and y axes. So the x-axis is y equals 0. That's the x-axis. The y-axis is x equals 0. So to find the x-intercept, which would be where it crosses here, which it isn't, we would set 0 equal to x squared plus 2. So we would get x squared is negative 2, but in the real number system, this does not exist. It's because you can't have the square root of a negative number, okay, in the real numbers. Okay, so now the y-intercept is the function evaluated at 0. F of 0 here is going to be x squared, 0 squared plus 2, because you're plugging in 0 for x, which is 2. So that's the point 0, 2, which we see right there. There's your minimum of your function. That's 0, 2. Okay, so the y-intercept is 0, 2. The x-int does not exist. Okay, so let's look at the domain and range. Well, the domain, you can see, is going to be starting at, well, actually, it goes, these parabolas, they're not a U. Do not think they're U. They actually go out forever. This goes out forever this way, forever this way. So domain is going to be actually here, all real numbers, except it's not going to be 1. So at 1, there's a break. Then from 1, then we go from 1 to infinity. The range, nothing starts to happen until y is 2, so it's going to be 2 to infinity. Okay? Alright, so before I go to Desmos, I just noticed that for some reason I couldn't spell out the word practice. Alright, so now we've done this. We just did this. We showed everything that we needed. So let's go to our Desmos calculator and let's graph it there and show what we got. Okay, so I've got f of x equals x cubed minus x squared plus 2x minus 2, no, all divided, needed parentheses there, all divided by x minus 1. Okay, so I lost it there because I didn't get the parentheses in. There we go. Alright, so there you go. You see a parabola. Again, you don't see a hole because, again, a hole has no dimension, just like a point has no dimension. So let's now make a table for x and f of x. Okay, so let's start at negative 2. Then we'll go negative 1. Okay, there we are at 1. We're undefined, which is what we thought we should see, not negative. I don't know what happened there. That should be negative 1, 0. It's kind of gone crazy on me here. There we go, negative 1. I don't want negative 1. I want that gone. I want 0, 1, 2, and 3. So again, at 1 it's undefined because that would be division by 0. So this is a just verification of what we've been doing, and you can see again your graph is actually a parabola with it that shifted up 2 units. Okay. So that's actually it for this video. So if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Also, I will say, so if you really want to get a feel for how these things work, go to that Desmos calculator and just start punching some things in and check out the results. Thank you and have a good day.